Okay, thank you for telling me. Anyway. Um, yeah, I definitely will share them. That's okay. Sorry for those who would watch it in the recording. I forgot to record like first 30 minutes of the lecture. Okay, never mind. Okay, so uh, virtual DOM is a representation, JavaScript representation of the real DOM. As I said before, React Element is, or maybe I didn't say it, but anyway, React Element is a main building block, not like, not main, but the smallest building block of React DOM. We have like React components and we have React Element. We build our React components with React elements, and we in fact can build another or not different React components with some React components that we created before. The virtual DOM is an abstraction of the HTML DOM. It is lightweight and detached from the browser-specific implementation details. So since the DOM itself is already an abstraction, the virtual DOM is in fact an abstraction of an abstraction. Cool, so virtual DOM has the mechanism of reconciliation. It is a process of updating your UI to match your application state. And yeah, there are some generic solutions to some algorithm that can compare our virtual DOM with the real DOM, but most of them has complexity of all and in the three I forgot this word. I'm sorry, guys. And 3 times, let's say like this. No, yeah. Yeah, where n is the number of elements in the tree, so it's pretty much a lot. If we use this in React, displaying 1,000 elements would require in the order of 1 billion comparison, and we would do like only one update of our page would take like 70 minutes. It's ridiculous. But instead of accurate diff algorithms, React uses some heuristic algorithm with complexity of n. That's pretty cool, so it's pretty fast. And this algorithm based on 2 assumptions that 2 elements of different types will produce different trees, and that the developer can hint at which child elements may be stable across different renders with a key property that we in fact used in the list creation before. In practice, these 2 assumptions are valid for almost all practical use cases, and it helps to reduce our complexity a lot. Don't worry that this information is not what you really need to know and to understand really good. It is just the process that when you would become probably like middle developer, you would really need to learn and understand. For now, for you as I would say students, it's just an overview. So cool. Yeah, how we rebuild the whole DOM? It's pretty simple. We have already our virtual DOM. It's t equals 1. When we change something, React creates a new virtual DOM, the second one, find the differences comparing with the first DOM, understands which of these differences require updates of the real DOM and applies these changes like only on particular nodes. Here is the example, like pretty cool. So we created a component that each second, you can see in the last line we set interval. Each second it render in our DOM new component, but React understand that we shouldn't change all DOM because, for example, hello world phrase didn't change. The only thing that changed is the time. So in fact, it's even don't change the whole node of H2. It simply change value of the date. So that's pretty cool, I would say. Okay, let's talk now about components. Yeah, here we can see a representation of different components of combination of these components on the page of Airbnb. And components, as you can see, that you split the UI into independent reusable pieces. And you can think about every component in isolation. So you don't need to think about it like I would put this component in this component and this component would be a part of this component and this would be my page. No, you should think about your component as independent piece of work that can be put pretty much anywhere on the page. Yeah, let's talk about what are the components. They are, in fact, functions that accept some input. We call them props, and return React element. So component is a function that takes some input and return React element. It describes what should appear on the screen. So here, H1 is element, but hello is already a component. It takes input like property name, value of which is React, and gives us an built H1 HTML element, let's say. So, so to close this topic about differences between components and elements, an element is a plain object. So component is a function, element is an object. It describes what you want to appear on the screen. It can contain other elements. It is, in fact, cheaper than create component elements in the regular JavaScript because regular components in JavaScript are pretty big. Let's say they have a lot of methods, a lot of values, and so on. But React components are small. They have only what they require to have, and that's why it is much cheaper and quicker to firstly find and understand what was changed in the virtual DOM. Typically elements are not used directly, but they return from components, as we can see. Cool. So let's go further. We have in React two types of components, in fact. There are a lot of different names of them, but they are only two. They're functional and they're class components. Yeah, the functional components are declared, oh my gosh, the class components are declared as class that extends from component class. It comes from React library, so we can either input it from React that we have in our project or write React.component in after the extends. Yeah, in either cases, our component takes props as an input and return an JSX tree as an output. Simply as that. Then JSX gets transpiled to React create element, and yeah, we've already discussed that, so I hope this is clear. Maybe you would have a question when to use a class component over a function component. As you can see, we extend our class component from component class from React, and it would have some methods, some mechanics that can be useful in the future. For example, class components would have lifecycle methods. You can look at them as some functions, some event handlers, because your component on your page can have like different stages of appearing, updating, and disappearing. We will cover this topic about lifecycle methods in the next lecture, because it's kind of advanced topic. But it comes from component class itself. We can use them. So if we need these methods, we use class components. If we don't use it. So most of the time we use functional components because they're smaller, they don't have a lot of like methods that we probably don't use, and yeah, for optimization, from optimization perspective, it is a better choice. Yeah, this is more extended example of the class component. As you can see, we have constructor where we get props, our properties of our component. We have to call super in it to initialize properties, so we can get them as this from this dot property props, and to get all our method that we might use from component class. Yeah, you can see that we bind methods like this, this decrease and this increase. They're actually methods, but they doesn't present it here. Yeah, they are methods, and we bind them to to know this. And I will explain this mechanics a bit later, so don't pay a lot of attention to that. We create also we create this state. State, it is a state of your component. It is used to change your components over time. Your component, look at it, and if state was changed, your component UI, your component view would be updated. So it is our mechanism that help us to trigger some events in the UI. We'll dive into this also a bit later. Cool. Yeah. Also, we can extend not only from component, but also React have something like pure component, and in fact, pure component is exactly the same as component, except that it handles the should component update methods. Yeah, this method is used, to define if our component should update its UI or not. Our component updates when either props or state of this component was changed. So if something that we get from our parent changed, or if the state of the component was changed, or the component itself was changed, we update our component UI. But we can control this. For example, sometimes when something is changing, we don't want the UI to be updated. Maybe something would happen, like, I don't know, maybe. And in this should component update, we can define that we don't want it to be updated. It is also a lifecycle method, so I won't dive into its mechanics and usage here, but this is something that allows us to increase and optimize our application. So each update of the component calls render function and it changes UI. It's even counting that React is pretty cool and can update certain nodes in the DOM, like simply comparing that it still needs some help from you as a developer, because sometimes the render function can be called when we didn't want that, and this actually happens really often, because especially when we're starting working with React, and our application can be not really performable and optimized. That's a bad thing, because in bad hands, React can be even worse than React application can be even worse from performance perspective than like core GS application. And this is something we need to take into consideration. Pure component help us to define that, but I was a bit confused, I'm sorry. So should component update, we get implementation like under the hood implementation from pure component. If you want to define it by our hands to like put something there in these methods, we can use it from simply defining these methods extending from simple components. So pure component is something that gives us a piece of optimization. Sometimes it's enough for application, sometimes it's don't. For example, sometimes we have like really big, I don't know, prop or state, and it is really expensive to go through this big structure, and it's in fact the check for changes in this structure sometimes can be even longer than render itself. So in this situation, it's better to not check if components should update or not. Yeah, this is hard to explain now when I didn't explain you much, but in next lecture, this stuff about lifecycle methods and should component update and pure component will be easier to understand. So don't pay a lot of attention to it now. Just remember it for now. So in React, we don't use how to say, we don't use extend for our components. If we want to create new component from already created one, we use composition. And this is like main concept, not main concept, but one of the main concepts of React. We don't extend our already created components if we need to create some like child components. For example, we have like component of the dialog or model window. If we want to create some specific one, we would have the same methods inside it. We would have pretty much the same UI, but maybe with some extra wrapper or something. It is it may look that it is a good idea to just extend our model window component, our custom model window component with our model component, and just, I don't know, go with this. But in fact, composition in React works much better, and there were no examples of like extending working better than composition. So yeah, this is pretty much it about components. Maybe you have some questions. Is everything that I'm trying to tell you clear? Because I'm not sure. Yeah. Extends component is equal to React.component. Yeah. It's just two options how we can like import our component. Let me find the example. Yeah, here it was really pretty far away. Oh, I pressed it. So yeah, here you can see we import React, and component class is held in React itself. So we can write extends React.component, or we can import component from React library as well using like curly brackets and use component without React before that. So it's simply the same thing. Depends on how we import component class. So yeah, cool. Let's return back to our slides. You have some time to ask me more questions. Yep. Okay. Oh, yeah, that's the last topic for us for today, state and props. We already know a bit about properties. It is something that we pass from our parent to our child. But let's talk about what state is. State of component is an object that holds some information that may change over the lifetime of our component. And these changes will be reflected in the UI. We should always try to make our state as simple as possible and minimize the number of stateful components. So stateful components are the components that have state. Yeah, the state should be simple because React will compare the previous state to the new state when it's changed. So you need to make it as simpler as possible to React to be quicker, to make this operation quicker. And in the class components, if you don't initialize state or you don't bind some methods, you don't need a constructor in fact. And in fact, state is the same thing, mostly the same thing as sorry, state is mostly the same thing as properties or as props, but it is private for your component. So it is fully controlled by the component itself, and it's not accessible to any components other than the one that owns this set of state. So you can change it, you can not you can access it directly only from this component that held this state. Is virtual DOM compared with DOM on time basis, or if something changes? No, virtual DOM is compared with DOM only when something changes. In fact, when state change. So This is state is used actually to change your component or your application through time, or sometimes as answer for some actions from user. So props are static, in fact, not like static, but they used to draw your UI. Only for that. You can't change props without state. You have to change state. Yeah, we have a few questions. What is the difference between using .bind this in the constructor and using arrow functions? The difference is that when you use arrow function right in the JSX, each render you would create new function, because anonymous arrow function that we put in our JSX is created in place right in the render, and it's not good from optimization perspective. So you don't need to create a new function over and over again. Moreover, if you pass this function in props to your child, props, each time when we render, this function would be created again. That means that props of the child is changed and your child would re-render when it shouldn't, because functions stay the same. So hope I answered your question. If we have, oh my gosh, yeah, so bind is better to use. If we have app built in React, we have DOM and virtual DOM in our browser. Not really. In browser, we have only DOM. Virtual DOM is abstraction that we have in React. It's simply, virtual DOM is a big object. It's just a giant object. Nothing similar with real DOM. We don't have in it. We can't see it in the browser in inspect mode or something like that. It is just a name of big object that represent real DOM. That's it. Okay. Cool. Yeah. Let's go further. Stateful stateless components. We already talked a bit about them, about stateful components. So stateful components know how everything works. It is just a container for components, for stateless components. It provides application data, and it performs data fetching. This is the functions of stateful components, what it usually do. Usually stateful components, it is wrapper or parent component that represents some business logic. For example, on the website, it can be some form that you submit. It would have the parent component of this form would have some state, for example, values of your inputs, probably some other fetch data, maybe it would be pre-filled or something like that. So your parent component is stateful. It keeps state of the business logic of this particular part of your application. All other components would probably be stateless. They don't need to know anything. They don't need to care anything. They can get everything they need from parent. And in fact, if, for example, one child of this tree would need to change some data that is required in a different child, it is easier to communicate them because you have like single source of truth for them in the parent component. Yeah, and function of stateless components. It know how to display some data. It receive and operate only with props. It don't have state, as it's already clear. And in general, stateless components can be defined as functional components because we don't have state, so we don't have most of the time we don't need any lifecycle methods. So there is no point to create extra to create our component using component class from React. There are some benefits of moving some components to stateless. For example, our application become more understandable. We always know which component is responsible for some data fetching, for some data changes, which component really do all stuff. And it is easier to debug, usually to find some problems, and in fact to implement. This approach reduces complexity of our application. Our stateless components become even more reusable because, for example, if we create button without any state, it can be used pretty much anywhere because it doesn't depend on anything pretty much. And yeah, using stateless components usually are pretty simple. Mostly they have UI. So that's why sometimes we call them dumb components or simply components, and stateful components or smart components, sometimes also called containers. And all these names are pretty much about the same. It depends on what you want to highlight, calling one component using certain name. This is the example of stateful and stateless components. So here, to do container, it is class components, it is stateful components. We defined. We didn't define state in here in constructor because we didn't need something like initial value for state, but we change it. You can see that in function set filters we call set state function, and the thing is that you need to understand that state is immutable. You can't simply write this dot state dot value dot key equals something. It won't call update of your application. Always when you call this dot state, always when you want to change your state, you have to call this dot state function. And be careful because it's actually asynchronous, and to read some value from like sorry. Yeah, I'm here. Sorry. To change our state, we call this state function all the time. It is synchronous. Sometimes a few calls of set state can be under the hood, can be transpiled into one just for optimizational reasons. And in fact, because set state is asynchronous, you can't, for example, read state in it. You can, but it's not guaranteed that the state that you read inside set state is actually updated. Because, for example, if this set state is second in the row, and you expect that you already, using the first set state, you already updated your state, sometimes it can be wrong. So set state in this example, this code, gets object. This object will be merged with your current state. So the values that you pass in this object will be added and probably will update values that you already have in your state. But if you want to update some state value knowing other state value, for example, to toggle some value, you have value in your state that equals true, and when you call some action, you want to change it to false, and then back to true, and then back to false. So you don't need to you need to know what value you already have in your state in order to update it correctly. So to read it in set state, you should pass the argument their function. This function gets state and props in argument, and this arguments that can be used to read your state. This thing is a little bit complicated now to understand just listening to me, but it will be simpler when you put your hands on React, I promise you. So just remember that state changed only using this .state function, and that's the only thing actually that is important. Okay, yeah. To-do container is a stateful container. It has some state. It changes it using some set state function in set filters function. And we have two child components, to-do list and filters pane. Yeah, okay, filters pane. They are stateless, that's why we define them as functional components. But we discussed we discovered that React has one direction data flow from top to bottom, so from parent to child using props. But how to change state of the parent from child, for example? For example, why would we need it? Imagine that I already told you about this example. Sometimes some child of the parent can change some data, and this data is required to draw some other child of this component, and this data is held in the parent. So to update one child of this parent, we need to call some function of the parent from another child. This is a bit complicated logic, but here on the diagram, we have this function that updates parent from the child. It is onDelete. It's called callback function, and callbacks pass via props from stateful component to their children, and it helps to mutate state of the parent component from its child. This is the example of such case. For example, we have here a list. It is a stateful component. Here an example item is also a class component, but it's actually redundant. We could have created it as a functional component. So list is a parent component. We have here constructor. We define some default state. And what we do is we call some function onDelete. So onDelete, it's like event handler. So we call method of the list onDelete. What does this method do? It calls set state and set items value of the state to some array. We simply pass this method, bind it to the child, and call this onClick. And this works. This works because we have closure here. This that we bind it in list onDelete. is like closed to closed in function on delete. So we won't lose it when we pass it in props. And simply calling it in the child on delete get this of parent and set some value that we pass it from the child. This mechanics is hard to understand from first glance, but you need some time to get into it, to understand it, but when you get it, you won't forget it. It's like pretty simple at this point. Yeah, maybe you have some questions about it. I'm open to explain you once more if it wasn't clear. Because this is in fact the last slide of the presentation. Yeah, and for some reason it's lagged. Okay, I hope so. Hope it's okay. Maybe some other question. There are 46 more. No, it is for next lecture. Maybe some other questions about presentation. Maybe you got some questions about React and more. Maybe other questions. Are we going to learn about lifecycle methods on the next lecture? Yeah. Me or other lecturer would tell you about lifecycle methods and why they're useful, how you can use them, and so on and so forth. So for now, you can understand them as some event handlers of the life cycle of your component. Your component has three stages. Oh my gosh, 3 stages, like mounting when your component first time appear on the page, updating when some props or state was changed, and unmounting when you remove your component from the page. And to every of these steps, you have a few methods that allows you to do some things in certain points of these processes of mounting, of updating, of unmounting, and you'll know in the next lecture why it is useful to do certain things, particularly in lifecycle methods, how you can use them to optimize your component. For now, it's okay for you to just assume that they exist. What materials would you recommend to learn React? In fact, I would recommend you, that would be boring recommendation, but to read documentation. But if it's too, I don't know, not boring, but it's hard for you to read plain documentation, it would be cool to find some course on YouTube. There are plenty of them, and people from like the top of the list describe everything pretty cool, and they show you some examples, and it will help you to learn quicker this thing, even quicker if you read documentation by itself. What do you think about Wes Bos courses? You know, I haven't heard about them, so I can't say anything. In the beginning of learning React, like basics, any course would be good. It's hard to mess up beginning of the React. It would be complicated to find something when you already learn the ropes of React, but for beginners, it's pretty much any course would be cool. I actually liked course from Traverse Media, React Crash course. He like updates his courses pretty much like 1-2 year every 1-2 years. So, and I really like him. And maybe the basics of React you will watch in 2 hours, I guess, or maybe even 1 hour. So to cover all topics we discussed today, once again, it will be enough. Okay, maybe some other questions. Okay, I guess there are no more questions. So thank you guys for joining. We'll see each other, I guess, on the next lecture on the lecture after next. So bye bye and see you.